Review sheet, section 2.1, part 2 continued. Number 5, a rectangular storage area is to be constructed along the side of a tall building. A security fence is required along the remaining 3 sides of the area. What is the maximum area that can be enclosed with 800 meters of fencing? Okay, we have one side that is taken up by a building, and we have to put in a fence on 3 of the sides. And we have 800 meters of fencing to do it. Let's label the 2 opposite sides X meters and label this side L meters. And so L plus 2X equals 800. And what we want is a function of a single variable that measures the area of all such rectangles. So if we solve this for L, we get L equals 800 minus 2X. And then the area function is length times width, so 800 minus 2x times x, or a of x equals 800x minus 2x to the second. If you want to put it in standard form, you can. A of x equals negative 2x squared plus 800x. This function is a quadratic function with a leading coefficient that's negative, so that means it does have a maximum value, and the maximum occurs at x equals negative b over 2a, where b is 800 and a is negative 2. So negative b over 2a is the negative of 800 divided by 2 times negative 2. Negative 800 divided by negative 4 is positive 200. Okay, so when the value of x is 200, the area will be a maximum. They want to know what the maximum area is, so we'll just use this area function and evaluate the area function when x is 200 meters. And we get 800 times 200 minus 2 times 200 squared, and 800 times 200 is 160,000, and then we're going to subtract 2 times 200 squared, which is minus 2 times 40,000, and so 160,000 minus 80,000 is 80,000. And that is measured in square meters. That's the maximum possible area for that rectangle. Okay, and number 6, find the smallest possible value of the quantity x squared plus y squared under the restriction that negative 2x plus y equals 1. Okay, so we'll solve this equation for y. Y is equal to positive 2x plus 1. And then in this expression, x squared plus y squared, we will replace y with 2x plus 1, and so we'll get a single expression in terms of one variable x, and we'll we'll square that binomial 2x plus 1, and we'll get 4x squared plus 2x for a total of plus 4x and then plus 1. And then when we combine like terms, we get 5x to the second plus 4x plus 1. This quadratic expression has a leading coefficient that is positive. So this does have a minimum value, and that's what we're supposed to find the smallest possible value. This will occur when x is equal to negative b over 2a. In this case, a is 5 and b is 4. So the minimum will occur at negative 4 divided by 2 times 5, or negative 4/10, or negative 2/5. Okay, so if we evaluate this expression at negative 2/5, that output will give us the smallest possible value of that expression. So we'll replace every x with negative 2/5. So we have 5 times the number negative 2/5 squared plus 4 times negative 2/5 plus 1. And now we just do a little bit of arithmetic. we have 5 times, when you square the number -2/5, you get 4/25. And then we're going to add 4 times -2/5. That's equivalent to adding 8/5. And it looks like we need to convert 1 to a fraction with a denominator of 5, so I'll write this as 5/5. And then 5 times 4/25 is just 4/5, so we get 4/5 minus 8/5 plus 5/5, and this all adds up to 1/5. So 1/5 is the smallest possible value that x squared plus y squared can have under this restriction where -2x plus y equals 1. Okay, in the next part, number 7, this one says a rectangle with sides parallel to the coordinate axes has one vertex at the origin, one on the positive x-axis, one on the positive y-axis, and its fourth vertex is in the first quadrant, and it's on the line with the equation 2x plus y equals 100. Find the maximum possible area of such a rectangle. Okay, so we'll draw another picture. We're told that the origin is one vertex of the rectangle, and then there's another vertex on the y-axis, another vertex on the x-axis, and the vertex of the rectangle that's in the first quadrant is on the line. It's a straight line. 2x plus y equals 100 is a straight line with a negative slope. So this represents the line. Well, I'm just going to rewrite 2x plus y equals 100 as y equals -2x plus 100. And we want to find the maximum possible area of a rectangle that is constructed in this way. This point in the first quadrant is some point on the line y equals -2x plus 100. Okay, well, the area of this rectangle in terms of x is just x. The length of this side is x. The length of the vertical side is -2x plus 100. So the area of that rectangle is x times -2x plus 100, or -2x squared plus 100x. Okay, this quadratic function has a leading coefficient that's negative, so it does have a maximum value, and the maximum value occurs when x is -b/2a. Okay, so for this function, a is -2 and b is 100. So the negative of 100 divided by 2 times -2, we're just going to get positive 25. Okay, so when x is 25, the value of this area function is a maximum. So we'll evaluate this function by replacing every x with 25. So we get a of 25 equals -2 times 25 squared plus 100 times 25. And then a little bit of arithmetic. The number 25 squared is 625, and 100 times 25 is 2500. -2 times 625 is -1250, and then -1250 plus 2500 is 1250. So I'll write that up here. A of 25 simplifies to 1250. That is the maximum area of that rectangle. Okay, the last problem on this set, number 8. Suppose that a baseball is thrown straight up and that its height, measured in feet as a function of time in seconds, is given by the formula h of t equals -16t to the second plus 64t plus 6. Find the maximum height of the ball and how much time it takes for the ball to reach the maximum height. Okay, well, this is another quadratic function with a leading coefficient that's negative, so it does have a maximum height or a maximum value, and the maximum value occurs when t equals negative b over 2a. For this function, a is negative 16 and b is positive 64. So the negative of 64 divided by 2 times negative 16 is negative 64 divided by negative 32, which is positive 2. So 2 seconds after the ball is thrown upward, it reaches its maximum height. That's measured in seconds. And then evaluate the function h when t is 2, and that value will be the maximum height measured in feet. So h of 2 is negative 16 times 2 squared plus 64 times 2 plus 6. And here we get negative 16 times 4 plus 128 plus 6. Negative 16 times 4 is negative 64. And negative 64 plus 128 plus 6. Negative 64 plus 128 is 64. And then 64 plus 6 is 70. So the maximum height is 70 feet.